I've tested almost every game that I own on an Intel Arc GPU to figure out just how many titles work on Intel's discrete graphics architecture and what sort of experience you can expect. Do all of the 250 games I played launch? Do they all play with no major graphical issues? Is Arc capable of playable performance in all these titles? I've got some great data to go through, but before we do, today's video is sponsored by the Gigabyte Aorus 16X gaming laptop powered by NVIDIA GeForce Graphics. This powerful system features up to an RTX 4070 laptop GPU and Intel Core i9 CPU with WindForce Infinity cooling technology efficiently handling 140 watts of GPU power. Of course, there's true AI capabilities here thanks to NVIDIA's Tensor Cores, which power excellent features like DLSS 3 and NVIDIA Broadcast. Plus, you get the power of the Ada Lovelace architecture for high-end ray-traced gaming. The Aorus 16X comes with a spacious 16:10 aspect ratio display, all housed in a chassis with slim bezels, a large battery, Wi-Fi 7, and a great build quality. To learn more about the Aorus 16X, check the link in the description below. So in this video, I've tested the Intel Arc A770 16GB, which is currently the fastest Arc graphics card on the market, in 250 of the games that I own. I actually own slightly more than 250 games, and of course, owning is questionable on digital platforms. But anyway, there's 250 games in this video. It's the vast majority of my game library. This includes games from as far back as the early 2000s, alongside plenty more from the last decade and a half of PC releases. With this sort of sample size, we're able to really dig in and see what Arc can do across a wide range of games from different eras, using different game engines and with different levels of graphical fidelity. Every game in this video has been tested using driver version 31.0.101.5592, which was the most recent driver available when I began testing. Intel updates their drivers regularly, so as of this recording, the latest version is 32.0.101.5762. Probably should shorten down those driver names. However, none of the issues described in this video have been resolved in that driver. As far as I'm aware, did go back and check most of them. I also didn't contact Intel about any of these issues ahead of time because most people actually buying an Arc GPU don't have a hotline to call up Intel and get specific games fixed or tips on how to resolve problems. So this is meant to be representative of someone that is actually going out and purchasing one of these graphics cards. The Arc A770 was slotted into my personal gaming rig, which includes an AMD Ryzen 7 7800X3D and 32GB of DDR5 6000 CL30 memory running the latest version of Windows 11. I targeted a 1440p resolution for all of the testing, a common resolution for this tier of GPU, and that is with HDR enabled as well. When testing all of these games, I was looking for each game to pass a set of criteria while also briefly examining performance and in-game settings. I looked for games to pass 3 tiers of launching: the game launching to the main menu in any form, the game launching into a level or gameplay, and the game launching without requiring any tweaks. For example, if a title did launch to the menu but crashed when attempting to load a level, that would mean a pass for launching but a fail for loading into the game. I also looked for any obvious visual artifacts. This includes missing textures or assets, visual glitches like shadow flickering, or any other major problems. And finally, I wanted to make sure each game is actually playable from a performance perspective. For most games, this meant achieving 40 FPS at a minimum. The second tier of this was assessing whether consistent 60 FPS was possible at a minimum without dips below this, even using the lowest settings. If a game could be played at a minimum of 60 FPS using low settings, that would pass both criteria. But if I only achieved, say, 45 FPS in the tested area, I deemed it playable without reaching a consistent 60 FPS. As you might expect, given the amount of games I looked at, I didn't play every game for hours at a time, and the goal of this video was not an in-depth benchmark comparison to other GPUs. That's just not feasible for this sort of video. What it does mean is that any graphical or performance issues that arise only from hours of play won't have been caught, and neither will in-game crashes that require you to get to specific sections of the game or play for certain amounts of time. When issues did arise, I allocated around 5 to 10 minutes to try and sort out the problem. If the game couldn't be fixed quickly, it's a fail. The good news is that the vast majority of the time, the Intel Arc A770 plays games without any issues. In 218 out of the 250 games tested, Arc passed with flying colours. This means a flawless launch with no graphical artifacts and playable frame rates. We'll get to the 32 games that had various issues in a moment, but initially we have 87% of games working very well on Intel's architecture. I think this is a pretty good result given the relative newness of this GPU and the depth of my games library that includes many titles released over a long period of time. The games that work on Arc aren't skewed to any era either. Most titles from this year and last year work well on the A770. Horizon Forbidden West, for example, yeah, you'll have to play using low settings, but a consistent 60 FPS experience is possible. As is the case in Like a Dragon Infinite Wealth using the highest settings, Resident Evil 4 using max settings without ray tracing, Hogwarts Legacy using high settings with XeSS, and Star Wars Jedi Survivor on medium settings. The further back we go in release date, generally we see better results from Arc as you would expect given the performance requirements of older games. Titles from 5 years ago like Gears 5 can be run successfully on Ultra settings, as can A Plague Tale Innocence and even Metro Exodus. Looking back 10 years ago, an Arc is very capable of a high refresh experience using Ultra type settings. This is the case in the areas I tested in Dragon Age Inquisition, Far Cry 4 and Battlefield 4. Most offered 90 to 100 FPS using the absolute highest settings with no issues. I was also impressed with the general compatibility of games that are very old by modern standards. If you really want to go back and play The Elder Scrolls Morrowind, Star Wars Knights of the Old Republic, Grand Theft Auto San Andreas, or Portal, again, all of those titles work just fine and pumped out hundreds of FPS. You are much more likely to run into issues with the way the games are made rather than issues with Arc GPU compatibility. It's pretty common to need to use workarounds or hacks to get support for modern conveniences like widescreen monitors or uncapped frame rates. 25 of the titles in my library had hard-coded frame rate limits, and several more had broken physics or other things at high FPS. One title was even capped to 30 FPS, which is pretty much a disgrace. In these flawless games, breaking down the results by the settings used to achieve over 60 FPS in the areas I tested, the vast majority of titles could be played using maximum or ultra settings. 86 titles using the absolute highest settings the game had to offer, 54 using the ultra preset, and 11 using very high without upscaling. Another 11 games could be run on at least very high with some form of upscaling. An additional 13 titles had no settings as they were lightweight or indie titles. So in total, that meant 175 games on Intel Arc ran perfectly fine and at a pretty decent quality setting. 16 titles could then be run on high settings, which were typically 1 or 2 steps down from max settings, 11 with high settings and upscaling, and 7 games were competitive titles that I chose to run on lower settings to achieve high frame rates on purpose. That's 209 titles running on Arc without having to resort to the lower quality presets. Rounding things out, there were 8 titles that didn't run especially well but were playable on lower quality settings. On medium settings, these were Halo Infinite, Mafia Definitive Edition, Pacific Drive, Ghost Recon Wildlands, Star Wars Jedi Survivor, and A Plague Tale Requiem. Low settings were required for Immortals of Avium and Horizon Forbidden West. The last title listed as Other is Battlefield 2042, which I couldn't test properly due to the complete lack of anyone playing this game. I also was pleased to see that 115 of the games I tested ran at, taking a general look at the frame rate, 90 FPS or higher in the area I tested or the built-in benchmark. It was more common across my library for a game to run at a high frame rate than near 60 FPS, though of course many titles are older and expected to run well on this sort of GPU. There's good signs here for gamers that typically stick to popular games and in particular popular multiplayer games. All of the games that I played that could be categorized this way worked flawlessly and generally with decent levels of performance. This includes Call of Duty Warzone, Fortnite, Counter-Strike 2, Apex Legends, Grand Theft Auto 5, Overwatch 2, Rocket League, PUBG, and Stardew Valley. Now, some of these games probably didn't run as well as I had expected. I'd put some parts of GTA 5 in that category and probably Call of Duty Warzone as well. But in both instances, with setting tweaks, you can achieve a good experience. Unfortunately though, in 10 of these games that did work and delivered playable frame rates, I reported noticeable frame pacing issues or stuttering. Some of these games, this is a known issue, not specific to Ark, for example, the Dead Space remake and some of the Assassin's Creed titles. In others like Days Gone and Crysis 3, this was more surprising. Other titles had major traversal stutter in areas that people have brought up previously, think the Star Wars Jedi games from the last few years. So 218 games worked anywhere from pretty well to flawlessly. Now let's talk about the 32 that had issues. First up, 12 of these titles had relatively minor issues that prevented the game from launching flawlessly. In all of these titles, the main issue was the game attempting to run on the integrated AMD GPU in my system instead of the discrete Intel Arc GPU, which is the primary GPU here. These games appear to be hard-coded to prefer to run on an AMD GPU over an Intel GPU, presumably to stop the game launching on the Intel iGPU in systems with an Intel CPU and AMD GPU. In this reversed situation, AMD CPU with Intel GPU, these games get stuck and either crash or deliver horrendously low performance. The simple solution to this is to disable the integrated graphics in my AMD CPU, which is probably a sensible choice given the 7800X3D's iGPU is not especially powerful. However, when inserting a competing Radeon GPU into my gaming rig, the Radeon RX 6650 XT, you don't need to disable the iGPU in any of these 12 games. They all run flawlessly on the first attempt, whereas on Ark, you need to apply the iGPU disabling fix. This could catch out novice users, and Intel should be advising developers not to code games in this way. In particular, Alan Wake 2 is a newer title that has this issue, which was released after Intel's Arc GPU series. 11 of these 12 games otherwise delivered a flawless and very playable experience once the iGPU is disabled, so they should be added to the previous 218 working titles, bringing the running total up to 229 games, or 92% of my library. 5 games didn't work at all, and these are the worst examples for Ark. 3 titles simply crashed immediately on launch: Avatar Frontiers of Pandora, Batman Arkham City, and SimCity 4, although SimCity does launch just to a permanently black screen. 2 further titles launched into the main menu but refused to load into a level, those being Left 4 Dead 2 and Saints Row 2, a couple of older games. The saving grace for Ark is that I also couldn't get Avatar to load on my Radeon RX 6650 XT, suggesting in that instance the issue is more with the game than the Arc GPU. However, for the 4 other games, the Radeon card had no issues, so these appear to be Arc-specific crashes. None were fixable in a reasonable amount of time using typical workarounds like resetting the settings to default, verifying the game files, restarting the PC, or disabling the iGPU. With that said, the crash rate for my game library in terms of crashes specific to the Arc A770 16GB is just 4 games out of 250, or just 2% of the titles examined. I was honestly expecting more titles to flat out not work, especially after some of the early reports surrounding Arc GPU compatibility, so kudos to Intel for working hard to get the vast majority of games working. I noticed graphical artifacts in 6 games. In BioShock Infinite, texture settings above low don't work and lead to missing textures, making the Ultra preset look like garbage. This is not an issue on the Radeon RX 6650 XT, which loads textures correctly in this configuration. In Dirt Rally, I noticed glitching on water streams in the background, appearing as weird black dots. This isn't overly distracting, but it's not an artifact that the RX 6650 XT renders, suggesting it's Arc-specific. In Ghost of Tsushima, rain doesn't render correctly using some graphical settings, particularly high settings, and this doesn't appear related to upscaling. When this artifact appears, rain looks awful. In contrast, the exact same scene using high settings on the RX 6650 XT works just fine. In Starfield, I noticed significant shadow flickering and artifacting along the edges of some objects, and this was universal across quality settings, high and low. This is another artifact that you don't get when playing on the RX 6650 XT in the same area with the same settings. The final 2 games had issues on both Intel and AMD GPUs, suggesting the problem lies with the game rather than Intel Arc. These are Grand Theft Auto 4, a game that doesn't correctly detect the amount of VRAM, and on high quality settings just completely fails to load objects, including the ground, even when forcing VRAM overrides. And The Witcher 3, which has some shadow flickering that I spotted in my test area. In summary, 2 games with visual issues and 4 with seeming graphical compatibility issues on Intel Arc specifically. I wouldn't exactly say that these problems are game-breaking in all instances, but definitely lead to an uglier presentation or compromised visuals relative to the same game played on a Radeon GPU. Lastly, we come to performance-related issues. In 11 titles, it wasn't possible to achieve 60 FPS on the Arc A770, and in 6 of these games, I'd say the experience is unplayable. However, 2 of these unplayable titles are Portal with RTX and Quake 2 with RTX. If you really wanted to play these games, you could just not run the RTX version, and neither title was playable on a competing Radeon GPU. You'd need to go with GeForce, probably a higher end card, to get either title running well. Let's focus on the games that run badly but aren't necessarily unplayable first. Starfield, in the area I tested, ran at less than 60 FPS using the lowest in-game settings, including XeSS performance, which makes the game look like poo. This game is playable above 60 FPS on an RX 6650 XT by contrast, though it still needs relatively high amounts of upscaling and low settings. Alan Wake 2 also struggles to hit a consistent 60 FPS using the low preset with upscaling, although you can settle into a nice 40 to 50 FPS experience here, which is definitely playable in this game. However, like with Starfield, this game runs better on a Radeon card and is more likely to deliver a consistent 60 FPS experience. The Last of Us Part 1 has been a pain point with Arc, as we've previously reported to Intel that the game crashed during shader compilation. That's no longer the case, but even using the lowest in-game settings with FSR performance, there are dips in the areas I played to below 60 FPS. Playable in this sort of game, but not ideal. Again, in contrast, the game runs much better on the RX 6650 XT to the point where you can use quality upscaling instead of performance while achieving better frame rates. Another example to show here is Senua's Saga Hellblade 2. Using low settings with XeSS performance, this is another game that struggles to consistently reach 60 FPS. This is a very slow-paced game that's perfectly fine to play at around 40 to 50 FPS, so you can use XeSS quality instead of performance for better visuals while maintaining some sort of playability. But again, the RX 6650 XT can deliver a consistent 60 FPS, still using low settings, in the same areas with better performance than Arc. While these titles don't run well, most would probably run okay if the Arc A770 was a little bit faster. That can't be said for some of the games I played though. Dragon's Dogma 2 is one example that is totally unplayable and needs significant driver work. I've already completed the game, so I had to start again, and even in the very opening area, I saw significant frame drops to well below 30 FPS, making the game lag hard and just feel like trash. This was using the absolute lowest possible settings in the game, which also made it look disgusting. In contrast, I didn't see any noticeable frame rate drops or issues on the RX 6650 XT. Yeah, you still have to settle for medium-ish settings with upscaling, but the experience is night and day better on the competing AMD GPU. Yakuza Like a Dragon from the outset runs at below 30 FPS with low GPU utilization on Arc, no matter whether you use the highest or lowest quality settings. There's also significant frame pacing issues, so it's not even a consistent 25 FPS, it ramps up and down as you move around, making the game feel awful to play. Again, this title runs just fine on a Radeon card and can even be enjoyed on ultra settings. I was especially puzzled by this game running so poorly when its sequel, which is very similar to this game and even has some of the same areas, actually runs quite well. Metro Last Light is the final title I wanted to highlight. This is a weird one, where the game initially appears to run fine, but within about a minute of gameplay, performance just completely falls off a cliff and delivers 25 FPS. This makes Last Light run significantly worse than its sequel, Metro Exodus. Again, no real issues on the RX 6650 XT, which allows you to play the game at higher quality settings and higher frame rates without performance suddenly tanking for no reason. What's less than ideal about the performance problems with some games on Arc is that generally this affects newer games more than older games. Dragon's Dogma 2 was one of the unplayable games, and that was released this year. Hellblade 2, Starfield, Alan Wake 2 were all released in the last 12 months. though would probably run fine on a more powerful Arc card. I believe Starfield was actually unplayable on Arc at launch too, which isn't great for people that wanted to jump into that title straight away. So here's the final breakdown of the 32 games with issues. 15 of these had more minor problems. Either they launched to the iGPU and could be fixed, or they couldn't achieve a solid 60 FPS but were still generally playable. The other 17 games had more noticeable problems, including 11 that were totally unplayable due to launch or performance-related concerns. That resulted in between 4 and 7% of my game library having showstopper problems, depending on how serious you rank the graphical issues. What is disappointing about this is that of the 32 games that had issues on the Arc A770, just 5 had the same issues on the Radeon RX 6650 XT, and there were only 3 games I'd describe as completely unplayable on that card. To be fair, I didn't test all 250 games on the Radeon card, only the ones with issues on Arc, so it's hard to say if only 5 out of 250 total games had issues, but it does point to fewer concerns on the Radeon side. Aside from testing games specifically, there's a few quality of life things that Intel needs to address with Arc. Their performance overlay inexplicably does not include an FPS counter, and yeah, you could use a third-party tool to get one, like Intel's own PresentMon, but it would be much better to have this integrated into the built-in tool. I use NVIDIA's overlay all the time to check my FPS when I'm optimizing settings, so to not have that with Arc is a bit baffling. I ran into multi-monitor problems trying to run my Alienware AW3423DW and a second monitor, the Cooler Master GP27U, at the same time with the GP27U over HDMI. It just would run into loops of trying to wake up the monitor but failing, something that doesn't happen on GeForce or Radeon GPUs in the same system, so that's a bit concerning. There's also the small point of power consumption. While not fixable with this current generation of hardware, the Arc A770 consumes more power than equivalent Radeon or GeForce cards. However, if we are talking about the hardware design, on a positive note, the A770 does feature 16GB of VRAM, which allows pretty much every game to be run using maximum quality textures, even if other settings have to be dialed back, so yeah, that's a nice bonus. All up, I've thoroughly enjoyed attempting to play nearly every game in my library on the Intel Arc A770. Bit of a crazy experiment given that I do own quite a few games, but lots of really valuable insights into where Intel is placed right now and what it's like to actually own and use Arc on a regular basis. When it comes to game compatibility, I think you could take as many positives out of this investigation as you could negatives. I tried 250 games, 218 of them worked very well without major issues, and as many as 233 of them ended up firmly in the playable zone. That's the vast majority of my game library, spanning everything from new titles to decades-old titles, working to a reasonable degree 20 months after this GPU launched. The downside, though, is that 5% of my library was essentially unplayable, either due to launch or performance issues. That doesn't sound like much, but most of the time, these very same unplayable titles were perfectly playable on Intel's nearest competitor, the AMD Radeon RX 6650 XT. Intel GPUs just aren't in a position yet where game compatibility is as broad as Team Red or Team Green, even if, generally speaking, a given game is likely to work on Arc just fine. What surprised me, though, is the sorts of games that work and don't work. I was expecting to find many more older titles that might have slipped through the cracks and end up without necessary driver optimizations, but that's really not the case. Most older titles work fine. It's actually more recent games that are more concerning, with issues in titles like Alan Wake 2, Starfield, and Dragon's Dogma 2, the latter of which is completely unplayable. This makes it difficult to recommend Arc for gamers that want to play major single-player titles close to launch. Intel has absolutely been working hard to ensure most games work on day one, and they've definitely ensured the most popular multiplayer titles work really well, but they now need to prove that Arc can be as reliable as Radeon or GeForce for the newest titles. A new architecture with much higher performance would probably help, but in the next 12 months, ideally there needs to be virtually zero major game launches that are broken on Arc. Old games are basically solved. Popular games are solved. If Intel can tick this last box, they'd be in a great position, but they're just not quite there yet. The Arc A770 and most of Intel's lineup ends up in a difficult place competitively. The A770 16GB is available for $270 US, but you can pick up a Radeon RX 6650 XT for just $220 these days, or an RX 7600 for $250. There's also the RTX 4060, though it provides lesser value as it's more expensive, hence why I used the 6650 XT throughout this comparison. Our most recent data has the A770 essentially matching these GPUs in performance on average at 1440p. This makes both the 6650 XT and RX 7600 the better value cards from a cost per frame perspective, as well as the more reliable cards with better game compatibility. Intel does have the higher quality XeSS XMX upscaler on its side, as well as double the VRAM, but it's still a difficult sell. I suspect most gamers would choose the card that is more likely to work with the games they want to play than the card with 16GB of VRAM but a chance of the odd unplayable title, though I'd certainly be interested to hear your thoughts in the comments. Until Intel can prove that they can deliver a great day one experience for all modern titles, ARC cards simply have to be cheaper than their competitors. They need to be in a place where you're tossing up, do I go with the cheaper card that offers 30% more performance but may struggle with the occasional day one title? Or do I go with the more expensive, slower GPU from the bigger brands that's more likely to work with every game? Right now, Intel is making it too easy to pick up a GeForce or Radeon GPU instead. With all of that said, I think Intel has improved from a position of probably don't buy this GPU unless you want to deal with early adopter issues to yeah, this is a viable option if the value proposition is right. Most games do work just fine on Arc. If you primarily play popular multiplayer games, Arc is a very suitable choice. The range of features and included software is respectable. It's just not the best candidate right now at its current price. But will a new generation change that? There's a chance. Will Arc Battlemage start from a much better position with a more solid foundation? Absolutely, and that's credit to the hard work Intel have put in to improve Arc with every update. So anyway, that's it for this look at 250 games on the Intel Arc A770. As I said, most of my game library. It's taken a while to get all this data in, but hopefully you appreciate an in-depth look that answers one of the bigger questions that I had about actually using an Intel Arc GPU. What is the game support like? How many games work? I think I've got a much clearer idea of what exactly is going on there in that front. So yeah, if you appreciate the work that we do here at Hardware Unboxed, then please consider signing up to our Patreon or Floatplane accounts. Links to those are in the description below. You'll get access to some cool benefits and perks like our monthly live streams, our Discord community, we've got BTS content, plenty of good stuff over there. So thanks for watching, and I'll catch you in the next one.